For a while now, me and my friend have been wanting to build a quadcopter. A quadcopter, you may ask? Yes, a quadcopter. It is as awesome as it sounds. The first successful quadcopter was invented in 1924, when French engineer flew his quadcopter 1,181 feet, which set a world record. At first, quadcopters were not that reliable because quadcopters had to be constantly stabilized, meaning that the pilot will have to make sure that all four propellers going at the same rate, which was too much work. It was not until flight computers were implemented to monitor the orientation of the copter and correct for instability by changing the revolutions per minute of the individual motors. A quadcopter is, according to Quadcopter HQ, a multi-rotor copter with four arms, each of which have a motor and propeller at their ends. Quadcopters are similar to helicopters in some ways, though their lift and thrust comes from four propellers rather than just one. Also, helicopters have a pitch or tail rotor that helps stabilize the craft, whereas quadcopters do not. In a quadcopter, two of the propellers spin in one direction, clockwise, and the other two spin in the opposite direction, counterclockwise, and this enables the machine to hover in a stable formation. Now notice in this definition they mention lift force and thrust force. To begin, according to NASA, lift is the force that directly opposes the weight of an airplane and holds the airplane in the air. Lift is generated by every part of the airplane, but most of the lift on a normal airliner is generated by the wings. Lift is a mechanical aerodynamic force produced by the motion of the airplane through the air. Because lift is a force, it is a vector quantity, having both magnitude and a direction associated with it. Lift acts to the center of pressure of the object and is directed perpendicular to the flow direction. There are several factors which affect the magnitude of lift. Notice that they say lift acts through the center of pressure. When thinking of the design of a quadcopter, it is easy to make the connect of how it acts through the center of pressure because a quadcopter is nearly symmetrical. Like mentioned before by Quadcopter HQ, two of the propellers spin in one direction and the other two spin in the opposite direction, and this enables the machine to hover in stable formation. Simple, right? It is because of this fact that when designing a quadcopter, you do not have to worry too much of the aerodynamics of its design. The need of keeping a quadcopter afloat is through its propellers. Awesome! This gives users the ability to begin liftoff in the Z direction. Well, where do we go from there? Another awesome part of the quadcopter is that it also moves in the X and Y direction using thrust force. According to NASA, thrust is a force which moves an aircraft through the air. Thrust is used to overcome the drag of an airplane and to overcome the weight of a rocket. Thrust is generated by the engines of an aircraft through some kind of propulsion system. In order to achieve thrust force, the rotational and translational motion are coupled from the four propellers. As the lift elevates the quadcopter in the air and moves it slightly, the thrust force can move the quadcopter forward and can also absorb a large portion of the lift force. The way that thrust force control is F equaling thrust, or the thrust force, equals power divided by velocity, which is air, where F is force and the power is the rate of the energy that allows the mechanical system to increase in energy at the expense of the electrical storage. What causes the lift is a free stream air velocity relative to the aircraft that creates the pressure distributions across the aircraft in each individual blade. These distributions can be controlled by cambering the blades and wings. Cambering is when the surface is curved. And the net pressure force is the lift force combined with the drag force. As you can see in this equation, L is the lift force, P is the pressure at any point of the surface of the quadcopter, P infinity is the original pressure of the air, and dA is the small sections of the surface area. Since the distributions can be controlled by cambering the blades and wings, the quality of the wings are very important to design a quadcopter that distribute the forces evenly. This is why videographers get the top quality wings to have the best control and stabilization of their quadcopter. From these propellers comes the RPM caused by the torque force. Torque force is a force acting on an object that causes an object to rotate. Think about it as if you were opening a door. In order to open a door, you have to push the side with no hinges. You are then putting a linear force from the axis of rotation. As you can see in this equation, T equals torque, F equals linear force, R equals distance measured from the axis of rotation to where linear force is applied, theta, the angle between F and R. Torque is in an equilibrium, so the quadcopter hovers. It is through the RPM of each individual propeller that gives a quadcopter the ability to go in any direction it wants to. If you want to lift a quadcopter in the positive Z direction, you will have to increase the RPM of all four motors simultaneously, vice versa if you want to descend. If you want to move forward in the Y direction, you will have to decrease the RPM of the two front propellers and increase the RPM of the two back propellers. To have this work properly, a quadcopter needs an MC multi-rotor control system. This makes 600 or more adjustments per second. Like I said before, this is tremendously hard for a human to do. Wow, quadcopters are awesome. Have I said that already? Well, either way, they are truly innovative. In fact, most decent quality hobby grade quads are aerobatic these days, capable of performing fast flips and rolls, yet can be put in easy, stable flying modes as well for beginners. Think of the possibilities. However, do not get the misconception that quadcopters are better than helicopters in every shape and form. While helicopters have two propellers that control its forces, a quadcopter has four, which creates more need to keep all propellers simultaneously working. This is why for large-scale transportation, people would rather use a helicopter than a quadcopter. Helicopters are just more stable. But either way, on a small-scale situation, quadcopters are the way to go. A tail rotor of a conventional helicopter does not contribute to the lift and is therefore a point of inefficiency. A quadcopter, there isn't this point of inefficiency, but having to continually slow down the speed and the props to remain in the air does waste a lot of energy. So quadcopters is mechanically more simple, but less stable and efficient than a helicopter when scaling up the size. For me, this beautiful device opened doors to everyday photographers and filmers. Quadcopters allow the common man to get any angle he wants as if he's rotating around a 3D program. This is why companies like DJI have innovated the small-scale quadcopter to products like the Phantom 1, which has a GoPro mount and an auto home landing. While the Phantom is more than $700 on the American market, making your own quadcopter can be as low as $170. Now that sounds like a deal, but remember, you are sending this device into the air, creating a huge risk of destruction if anything fails. Oh, technology. And to think that understanding the mechanics and how they generate these forces made this all possible. With all this knowledge, I should be able to make my own successful quadcopter, right? And if you still have not learned anything from this video, at least remember, force equals mass times acceleration. It just is.